Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Today's problem is another problem in my mental playlist. Please see description for the link and for the links of previous installation of the same problem, because it's continuation of the previous problem. And I want to solve the same problem about the platform that moves with velocity v and cannonball is fired with velocity v0, but I want to solve it differently, a little bit differently, and come to the same result. Before we were solving it in the system coordinate related to Earth. And now I'm saying let's use the same logic, but use it in the system of coordinates that moves with this speed v. If it moves with this speed v, then initial momentum would be m plus m multiplied by 0, because in this system of coordinate everything is at rest. Center of mass is moving, and then it's everything at rest. And then we can have the same part mv0 plus mu, and it would be no different than in the very first problem when we have mv0 plus mu, and we have mu, I just repeating myself, minus mv0, and we have u equal m over m capital v0, and we have the same 0.5 as before. So in this system of coordinates that moves with the velocity v, nothing, the same problem, the same result. But then we come back to Earth, and in the system of coordinate related to Earth, everything has to be adjusted, and the speed of the cannonball would be actually v plus v0. Of course, this v plus v0, if v is 10 meters and v0 is 500, we can ignore this. The velocity of the cannonball would be the same, but strictly speaking, of course, it would be 510 instead of 500 meters per second. And this would be in relation to Earth. But it's important if we will decide where this cannonball will fall, how it will travel, what parabola it will fly. But they're not asking us about this, they're asking us about the platform. And platform was moving, the coordinate system is moving with speed v, and that means it will be slowed down by this u, and this would be v minus u. So 510 minus 500 was important for this small mass, but for this mass v is 10 and u is 0.5, and 0.5 it's 9.5. It's noticeable. Noticeable degradation of speed if it's moving this way, right? And accordingly, if it's moving that way, we will be solving it in the system coordinate related to the center mass that will be moving here, and we will receive this u in this system of coordinate, and then those have to be added, twice minus minus, and it would be not 9.5, it would be 10.5. Basically, that tells you that good system of coordinate can somehow simplify the solution. I hope this will helpful, and if so, like, subscribe. I am not tired to suggesting this, and see you next time. Thank you.